Please see an example of the question that we were going over in the lesson today. That was quite lengthy. Just to clarify, you've got your A and B given in these two coordinates here, with a midpoint M being here, and you want to prove that this is half of this. So first of all, from A to B, you can simply use Pythagoras to look at distance between those 2 points, given that the coordinates are given in x1, y1, and x2, y2. And then you can just look at difference in the x values and the difference in the y values denoted by x1, x2, y1, and y2, squaring each of these values and then square rooting it. So for AB, we just expand each of these and get each of these here. So I know it's a bit complicated and there's a lot more going on because of the subscripts with the 1s and 2s down here, but you may pause and look at that. From A to M, on the other hand, you're going from A point here, just x1 and y1, to these points given by M. So we can say these can be split up into two parts by thinking about what happens when we add fractions. From A to M then, we can look at difference in the x values. So to get from this x value to this x value, I'm simply going to take this and take away this from it. So inside that first value, which I'm going to square, which is difference in x, I get this, and the same is true for y. Looking at it carefully, all I'm doing is taking away by collecting like terms, and I can see I can subtract x1 from x1, but this is half of x1, so x1 take away half of x1 leaves me just half x1, and the x2's, which is half x2, I'm just taking away from what we have left. This does not collect with anything else. On the y's, a very similar thing happens, and I'm left with this. So I'm going to be squaring each of these differences, and whilst it's a fraction, it's fairly tricky looking, we can just do one at a time. So x1 over 2 squared is going to give me x1 squared over 2 squared, which is 4. Then I'm going to have x1 over 2 multiplied by minus x2 over 2. I know that this is going to happen twice because I'm also going to do it the opposite direction. It's going to be minus x2 over 2 multiplied by x1 over 2. That should simplify nicely to this. And lastly, when I square the negative x2 over 2, I end up with x2 squared over 4. The same happens with y's. And lastly is that simplification, which brings it to this. We can then collect all of these because they have a common denominator. And then you can see, using your index laws, you can separate your fraction where you're square rooting both numerator and denominator. And lastly, you square root of your 4 to get your 2, and you can see that AM is the same value that we had for AB, but divided by 2. Therefore, AM must be half of AB.